Today we shall discuss exercise 5.4 of class 12th. Let us begin with the first question. Let y is equal to e power x upon sine of x. Differentiating with respect to x on both the sides, we get dy by dx is equal to d by dx e power x whole upon sine x. Here we apply the quotient rule. Dy by dx is equal to, in the denominator we take the square of the given question denominator. Here it will be sine square x. Now in the numerator you will have this denominator as it is, means sine of x as it is, multiplied by the derivative of the numerator, which is d by dx e power x, minus big bracket starts numerator, that is e power x as it is, multiplied by the derivative of the denominator, which is sine of x. So we get sine x into d by dx e power x minus e power x into d by dx sine of x. Now what is d by dx ex? It is e power x as it is. Okay, so we get sine of x into e power x minus this e power x as it is, multiplied by what is the derivative of sine x? It is cos of x whole upon sine square x. Now we have used these two formulae here. D by dx e power x you will get e power x as it is, and d by dx sine of x is cos of x. Now from there you can take e power x common. We get e power x bracket starts sine x minus cos x whole upon sine square x. A very simple question, but I insist that you please revise and learn all the formulae. Only then this exercise will be easier for you. We come to the second question, y is equal to e power sine inverse x. Differentiating both sides with respect to x, we get dy by dx is equal to d by dx e power sine inverse x. So what we do is, as we know, derivative of e power x is e power x as it is. So derivative of e power sine inverse x will be e power sine inverse x as it is, multiplied by the derivative of the power of e. What is the power here? Sine inverse x. So I repeat, e power sine inverse x as it is, multiplied by the derivative of sine inverse x. Whatever is written in the power of e, you will calculate the derivative here separately. This is the chain rule we have applied here. Now e power sine inverse x as it is, another formula which you have to memorize is derivative of sine inverse x is taken as 1 upon under root of 1 minus x square. So you put this formula here, you get e power sine inverse x multiplied by 1 upon under root of 1 minus x square. Now you can take the common denominator here. Answer will be e power sine inverse x whole upon under root of 1 minus x square, where we mention that x belongs to minus 1 and 1 because it is considered that under root of 1 minus x square is defined for minus 1 and 1. So if you write this answer, it is very correct. Next question. Third question, y is equal to e power x cube. Same format, differentiate with respect to x, we get dy by dx is equal to d upon dx e power x cube. So what you will do is, the derivative of this term will be this term as it is, multiplied by the derivative of the power. So we get e power x cube multiplied by the derivative of x cube, which is the power of e there. So the answer is e power x cube into the derivative of x cube is 3x square. What formula I have used here is d by dx x power n is equal to n x n minus 1. This was also a very simple question. Next, y is equal to sine of tan inverse e power minus x. Please listen very carefully. The format will be the same. Differentiating with respect to x, dy by dx is equal to d by dx sine of tan inverse e power minus x. Now what you have to remember is the formula d by dx sine x is equal to cos x. Now please, here what is done is this x which I am taking sine of x, this tan inverse e power minus x is the substitute for x. When the question is sine x, I write answer, derivative of sine x I write cos x. Now sine of tan inverse e power minus x will be cos of tan inverse e power minus x. I have underlined here here and here the same things means this x is getting substituted for tan inverse e power minus x. This is how I have written here. There is no need of any confusion. Cos of tan inverse e power minus x. This is the derivative of sine of tan inverse e power minus x multiplied by the derivative of whatever is in the bracket. We have to take the derivative of that bracket separately. So I will write d by dx tan inverse e power minus x. First I solved for sine of this term. I wrote the answer and I have multiplied this bracket term separately. Now, what you will write in the answer, cos of tan inverse e power minus x as it is. Again, a formula to be memorized, tan inverse x ka derivative is equal to 1 upon 1 plus x square. Now, when I will take the derivative of tan inverse e power minus x, what is being happening is the x, this x here is being substituted by e power minus x. So wherever in this formula I have used x, I will write e power minus x. So what you will get is 1 upon 1 plus e power minus x whole square. This is not that difficult as it assumes to be. Wherever this x had come, I have substituted in the formula e power minus x for x. That is why I have underlined all the terms. Now till here I think I have made it clear. Multiplied by derivative of e power minus x. See what type of chain rule we are applying is, first we calculated here the derivative and this term derivative was calculated separately. Now I calculated the derivative of this term and this term derivative e power minus x will be calculated separately. So if you go step by step, you will not get any confusion. Now we get cos of tan inverse e power minus x multiplied by 1 upon 1 plus e power minus 2x. This minus x whole square I have taken as e power minus 2x multiplied by. Now what is the derivative of e power minus x? It will be e power minus x as it is multiplied by the derivative of minus x. Just like as I told you in the previous slide, when we calculate the derivative of e power something, we write the term as it is multiplied by the power of the derivative of the power separately. So now the whole question will be copied as it is, cos of tan inverse e power x multiplied by 1 upon 1 plus e power minus 2x multiplied by e power minus x multiplied by the derivative of minus x, which is minus 1. So this is the solution, and now we will reframe this answer. This minus 1 will be written as here minus, okay, e power minus x from here comes here, then cos of tan inverse e power minus x, this is copied here, and in the denominator you get 1 plus e power minus 2x. This is the answer to the question number 4. Moving further, question number 5, y is equal to log of cos of e power x. Differentiating with respect to x, we get dy by dx is equal to d by dx log of cos of e power x. Again a formula, derivative of log x is calculated as 1 upon x. Now wherever, as I told you, wherever it is x, you will be substituting this by cos of e power x. Be very careful. You get 1 upon x, so I will be writing 1 upon cos of e power x as it is, because this is the log. Log of x is 1 upon x, so log of cos of e power x will be written as 1 upon cos of e power x multiplied by what is in the bracket. The derivative will be calculated separately, so d by dx cos of e power x. Okay. Now again a formula, cos of x is minus sine of x. This x here, this x will be replaced by what is substituted for x. It is e power x. So wherever in the formula you are writing x, you will write e power x, right? So your answer comes out to be 1 upon cos e power x into this cos e power x. What is the derivative? Minus sine of e power x. Okay. Multiplied by derivative of e power x again. So this is a chain rule. First I calculated the derivative of this term, then the derivative of this term, and then ultimately d by dx e power x will come like this. So you combine both these two terms, you will get minus sine e power x upon cos of e power x multiplied by what is the derivative of e power x? It is e power x. So this e power x will come here. Now you please see carefully, sine of e power x upon cos of e power x. This term is written as tan of this whole term you can write as tan of e power x. So your answer comes out to be minus tan of e power x into e power x, and which can be reframed as minus e power x into tan of e power x. So this was the question number 5. We move further. Y is equal to e power x plus e power x square plus e power x cube plus e power x power 4 plus e power x power 5. Differentiating with respect to x, we will find the derivative of each and every term because addition sign is here, so there is nothing to worry. dy by upon dx is equal to d by dx e power x plus d by dx e power x square plus d by dx e power x cube plus d by dx e power x power 4 plus d by dx e power x power 5. So what is the derivative of e power x? Answer is e power x as it is. So answer comes out here, e power x. Now d by dx x square will be written as e power x square as it is multiplied by the derivative of x square, which is the power of e. Right? Similarly, you will get e power x cube multiplied by the derivative of x cube plus e power x power 4 multiplied by the derivative of x power 4 plus e power x power 5 multiplied by the derivative of x power 5. Now, very simple. You get e power x into e power x power 2 as it is. What is the derivative of x square? You get 2x. Right? So, this derivative you will pick from here, from this term derivative, and you will write the answer here, 2x. Next, e power x cube as it is multiplied by the derivative of x cube. The answer is 3x square. It is written here. Right? Now, e power x power 4 as it is multiplied by the derivative of x power 4, which is actually 4x cube. Very simple. Plus e power x power 5 multiplied by the derivative of x power 5, which is written as 5 into x power 4. Okay, now this is actually the answer. You will be reframing it a little bit. It is e power x plus this 2x will come in the beginning. You will get 2x e power x square plus 3x square e power x cube plus 4x cube will come in the beginning, e power x power 4, and plus 5x power 4 in the beginning multiplied by e power x power 5. It is again a very simple question. We move further. Question number 7. Please be a little careful. It is not that difficult, but still y is equal to under root of e power under root of x. Now this outside wala under root, which is this under root, this can be replaced by 1 upon 2, which I have written it here. So I have written is y is equal to e power under root of x whole power 1 upon 2. Okay. Now differentiating with respect to x, we get dy by dx is equal to d upon dx e power under root of x whole power 1 upon 2. The formula which I will be applying here is d by dx x power n is equal to n x n minus 1. So this 1 upon 2 will come in the front. 1 upon 2 e power under root of x whole power 1 upon 2 minus 1 multiplied by d by dx e power under root of x. This will be again the chain rule out here. So you get the answer 1 upon 2 e power under root of x whole power minus 1 upon 2 multiplied by. Now what is the derivative of e power x? It will be e power under root of x as it is multiplied by the derivative of under root of x. Whatever is the power of e, we will find the derivative separately. Okay. So you get here 1 upon 2. This is e power under root of x minus 1 upon 2. So I will take it in the denominator. It will become positive. It will be 1 upon under root of e power under root of x. Very simple. Multiplied by e power under root of x as it is. Now what is the derivative of under root of x? This can be written as d by dx x power 1 upon 2. Now this question, this e power under root of x, I have taken it here in the numerator, and in the denominator you are getting 2 into under root of e power under root of x. Here I am solving d by dx x power 1 upon 2, which will be 1 upon 2 multiplied by x power 1 upon 2 minus 1. So you get e power under root of x whole upon 2 into under root of e power under root of x multiplied by 1 upon 2 multiplied by x power minus 1 upon 2, and this minus 1 upon 2, it will be taken in the denominator, and you will get this 2 multiplied by this 2 will give you 4 in the denominator. The answer is e power under root of x whole upon 4 under root of e power under root of x multiplied by 1 upon under root of x. You can still consolidate the answer, and you can get e power under root of x whole upon 4 into under root of x multiplied by e power under root of x. If you do this question step by step, it will be not that difficult. Question number 8. Again a simple question. Y is equal to log of x where x is greater than 1. You will do it in the same format. Differentiate with respect to x. Dy by dx is equal to d by dx log of x. Now the formula first of all is d by dx log of x is equal to 1 upon x. This is the answer to the derivative of log of x. Now here wherever is written x, this x, you will get 1 upon x is your answer, and here this x is being substituted by log of x. So wherever in the answer you are writing x, you will write log of x. Now the derivative of log of x will be 1 upon log of x, right? Multiplied by the derivative of whatever is in the bracket, you have to find the derivative separately. So it will be d by dx log of x. I repeat, derivative of log of x will be 1 upon log of x multiplied by the derivative of log of x. Okay. So this will give you 1 upon log of x into, again, what is the derivative of log of x? It will be 1 upon x. So your answer will be 1 upon x log x. Very simple, where x is greater than 1. Next question. 9th question. Y is equal to cos x upon log of x where x is greater than 0. We will write differentiate with respect to x on both the sides. Dy by dx is equal to d by dx cos of x upon log of x. Here you will write the quotient rule. There will be a big line here. In the denominator you will get the square of the denominator log of x ka whole square. In the numerator you will get the denominator as it is. It means log of x as it is multiplied by the derivative of the numerator which is d by dx cos of x minus big bracket starts numerator cos of x as it is multiplied by the derivative of denominator which is d by dx log of x. Now the formula you have to learn is d by dx cos of x is equal to minus sine of x. So coming back to the question, you will get log of x into minus sine of x. This derivative of cos of x here, the answer to this is minus sine of x. Okay. Minus this minus will come as it is cos of x multiplied by d by dx log of x. Now what is the answer to the d by dx log of x? Answer is 1 upon x, as I have mentioned here in the formula also. D by dx log of x is 1 upon x. So now reframing the answer, we will get minus sine x log x minus cos x upon x whole upon log of x whole square. Okay. Now in the numerator you are getting here x. You please take a big long LCM here. You will get this x will be multiplied by this term. You will get minus x sin x log x minus cos of x whole upon x whole term upon log of x whole square. So this x will be multiplied by log of x whole square. You will get minus sin x log x minus cos x whole upon x into log x whole square. Right? You can take minus as common in the numerator. You will get minus bracket starts x sin x log x plus cos x whole upon x log x whole square where x is greater than 0. Clear? Next question. Question number 10. Y is equal to cos of log x plus e power x where x is greater than 0. Differentiating with respect to x on both the sides, you will get dy by dx is equal to d by dx cos of log x plus e power x. Now what formula you are using is d by dx cos x is equal to minus sine of x. Now what is being substituted for x in this question? Wherever you are writing x, here I am writing x, here also I am writing minus sine of x. X is being substituted by log of x plus e power x. So wherever in the formula you have written x, you will write log x plus e power x. Clear? So the derivative of cos of log x plus e power x will come out to be minus sine of log x plus e power x, right? Multiplied by whatever here is in the bracket, the derivative will be calculated separately. So you will get d by dx log x plus e power x. Simple. Now answer is equal to minus sine log x plus e power x as it is multiplied by d by dx log x plus d by dx e power x, right? So you get minus sine log x plus e power x multiplied by what is the derivative of log x? Answer is 1 upon x plus d by dx ex. What is the derivative of e power x? Answer is e power x. So your answer is minus sine log x plus e power x into 1 upon x plus e power x. This is the answer, but you can reframe it a little bit. You will get minus sign of log x plus e power x multiplied by, please take a common denominator out here. You will get x in the denominator, and the numerator you will get 1 plus x e power x. This can also be very valid answer, but if you want to match your answer with NCERT, you will write this portion in the beginning. So you will get minus. Now here, please write separate denominators. You will get 1 upon x plus x e power x upon x. X will get cancelled. You will get minus, bracket starts, 1 upon x plus e power x multiplied by sine log of x plus e power x, where x is greater than 0. So this comes to the end of the exercise. Question number 10 is solved. I hope you understood the whole questions of today. If you have any comment, please you can ask me in the comment section. If you have any doubts, feel free to ask me again. Please like and subscribe to my channel. Thanks for watching. Stay safe, stay blessed.